Good afternoon, everybody. It's my pleasure to introduce our guest speakers for this session, two long-term InterSystems partners. And we'll start with Thomas Howe, as mentioned, founder of Hesper, Speedminer, and EliteSys, based in Kuala Lumpur, Malaysia. Has more than 30 years of health technology experience, including both TrackCare and IRIS for Health data platform. And Thomas was awarded the Enterprise Data Scientist Award by the Prime Minister of Malaysia in 2017. And Thomas will tell us about data interoperability and visualization in the context of large language model-driven AI on the IRIS platform. So please welcome Thomas.
Thank you, Julian, and thanks to InterSystems for having me on the stage.
I don't have the...
I missed my control here. Oh, yes, thank you. Okay, I'm really excited to present to you. I've been spending all my life with InterSystems technology, about 31 years up to now. And we have been doing a lot of data visualization. So this is the topic that I like to talk about. But since everybody now is talking about AI, so my presentation today will be more focused on the data visualization in terms of machine learning and AI. So these are three things that I will talk about: the exploratory data analysis in the machine learning context, the natural language, the SQL, and the retrieval augmented generation, which I think quite some of you all have seen the presentation throughout. Okay. I recorded this yesterday. This is our machine learning module, where you can build any models, including the medical images prediction. So here I just show that we load some data, and you can see all this data from TrackCare. So it's our demo database. You can go into a column and see what are the possible value of the columns. This is normally what we like to do in EDA, to understand our data better. Then we will understand a little bit more to see the count, the frequency, the mean, median, and we can have a visualization to see our now value in the database. So you can see the states majority are filled up except the past. The white lines are those that is filled with the data, and the rest are missing value. So you can have a very clear understanding of your distribution of your data in the table. So this is one thing. You can have other visualization as well. I run through a bit fast because I have 15 minutes here. So, so we can do all this data manipulation using IRIS or embedded Python, or actually the tools you do not need to do any scripting or programming. So this is a histogram with a box plot that you can see the anomaly detection. You can select the box plot and you can change the column to age at emission, and you say, okay, you just run, you'll regenerate a new chart for you, without you have to do all the programming. Okay, so this data looks perfectly symmetrical. And if you like to generate something like a tree map, so you just have to spell out which columns that you want to present. So you can have the chart generated for you. Okay, you can also look at another chart type, sunburst. So this is quite interesting one. You can select like February, you focus on the February, you can see the distribution of the data. Okay, for those like to have animation, you can choose this chart type. Normally we'll display over the year to see how the performance changes over the time. So over here, I choose a different department to view. Some of the department don't have any business or any activity or certain quarter, so you can see that. Okay. So next, I like to show to your natural language to SQL. So this is where you can type human language to query your database. So your TrackCare or any database that you load into the IRIS, you can use any language. You can use Thai, you can use Bahasa. You can type mistake like mix of English with the Bahasa, and the system will be able to understand and translate this to the SQL. Okay, so you can see the data being pulled out based on your query. The SQL generated is a little bit complicated. Sometimes the technical people do not even know how to write the filter correctly. So after you pull the data, we can further analyze this data set. For example, I want to ask the question like, show the average length of stay, yeah, break down by the doctor. So every doctor, what is their average length of stay? So some doctor like to keep the patient in the hospital longer. Hospital might not like them. Yeah, we want to be a fast turnover. So here is our data. This is a fake data anyway. So you can see all these doctor, and you might want to ask the system to list out the top 3. Yeah, for example, so that you're lazy or sorting them yourself. So you want to see the doctor with the highest length of stay. Yeah, the 3 doctors. So again, use human language instead of SQL. Yeah. So we run this, we get the 3 doctors verified to be correct. Yeah. So you can further ask other questions. For example, you like to see the breakdown of the number of records for each state or each doctor or each department. You can just easily ask the system. My demo database is from Sydney, so there's a lot of Australia states here. Yeah. So for example, it mixed with some data that I don't want to see. So I want to see only Australia states. Yeah. So I can add additional condition, Australia only. So, and one thing you have to remember, we saw this Australia capital territory. That is not a state, yeah. You cannot fool the large language model. They know that it is not Australia state, even though they say Australia, yeah. So you exclude them, those records, yeah. So I also want to plot a chart, yeah, because we are talking about visualization. Tabular is a visualization. So here I purposely make some mistake. For large language model, they can understand what you're trying to say, yeah. So some mistake is okay, acceptable. They'll correct it for you. They don't write the wrong spelling, they write it correctly for you, put it in the chart, yeah. Okay, next area I want to talk about is back to the machine learning module, that we can use the same module to design RAG, the retrieval augmented generation. So I load a track care emergency training manual and also some video, and I give a name to the model that later on we'll use that model to query. So it's our plan to have a RAG for customer to query how to do things in track care. So they don't have to ask the support people. So on here, I selected the modules here, the model here, and I want to ask the question, explore the workflow to assign bed to a patient. Yeah, so I know a lot of you all may know how to do it in the track care, but if you are new, and easiest way is to ask a large language model. It will go through the documents and extract the answer and produce to you in a nice format. Remember this format. Later I will use another large language model. They give the similar answer but different format. Over here, we have the source document that give you the knowledge. You click on it, you go straight to the documents. Okay? So you know where is the place that explains. So you have thousands of pages. You don't have to go and do a control find. So I use another model called Mistral. So some of you ask, what is the large language model we are using? This one is Mistral. Yeah. So it's free of charge. It's open source. But we fine-tune with the healthcare knowledge. You can see that the answer here is slightly different from the earlier. So you have a choice of multiple large language model that we generally go through the training so that you understand some medical term. Okay, so and we will give it to you to run it from your local machine. You don't have to link to ChatGPT if you don't want to. Yeah. So now I'm using a video. I have 1.5 hours video demo of a track care. So I want to ask a question. How does the doctor find out their workload? Okay, so those of y'all who know, you go to the clinical workbench, yeah, so clinician workbench, yeah. So we will ask, and the system will go to the video and convert it to text and get you the answer. So the source information, the context, generate the context is here. If you click on it, then the system will bring up the video on that portion that I don't have the voice to show to you, but the trainer actually explained. First is about the OT schedule and all these things. Then towards the middle, it will bring up and talk about the clinical workbench, clinician workbench, sorry. Yeah, so the doctor name is here. You can see the doctor name, the calendar. This is all his schedule. So this is his workload, yeah. So all these things you can ask with human language and get your answer, okay? So all these things is done with IRIS with embedded Python. So any question, you may ask me later on. Thank you.
Thank you, Thomas. Thank you. Next, please welcome Daniel Wang, co-founder and CTO of Jonda Health, established in Singapore in 2021, pioneering health technology solutions focusing on data and systems interoperability, and will be showcasing a transformation engine, Jonda X, they developed, and how the IRIS for Health data platform empowers them to develop it fast and to operate it at scale with thousands of lines of code, multiple large language models, many API calls, using several programming languages to implement character recognition, and to do so very, very quickly in just a few seconds to get a response. So please welcome Daniel.
Thank you, Julian. Hi, today I will be talking about interoperability and innovation with InterSystems. When we talk about interoperability, we're talking about moving data securely from one source to another source, and we have standards to help move this data. FHIR, HL7, these are standards that define the content and structure of the files. We also have standards like LOINC, ICD, SNOMED, that defines the terminology of the data. Hi, my name is Daniel Wang. I am the co-founder and CTO for Jonda Health. Jonda Health was started over 2 years ago because we realized that there is a problem for data silos, data not moving from one source to another, as well as data usability. What do I mean by data usability? Say one system is using HL7 as a standard. Another system is using FHIR. The two systems cannot talk. And that is a problem. Let's talk more about the interoperability problem. Not only are we talking about messaging standards which don't match, InterSystems has provided tools to address this, which is fantastic. But we also have issues with the terminology. Take, for example, when you travel to a different country, you'll notice that everybody seems to use a different power outlet. These are all standards, right? The power outlets are different standards. So, what do? Someone told me, let's use a single standard. So I told them, okay, first let's decide which side of the road we should drive, on the left or on the right. If we cannot even decide on a binary choice, forget about deciding on a power outlet or which interoperability standard to use. So we thought about this problem, and the solution is pretty obvious. Use a power adapter. We did our research. For the white blood cell biomarker, there were at least 21 different ways of expressing the biomarker, different names, many of which are non-standard, as well as different languages, of course. And for the white blood cell itself, there were at least 58 different ways of expressing the unit of measurement, some of which need to be recalculated if you change the unit of measurement. So what do? You've got a fire file coming in, your system is fire compatible, excellent, but the content is not compatible to your system. What do? You use a power adapter, and that's where Jonda X comes in. Otherwise, you enter the data manually. This takes time, costs a lot of money, uses a lot of manpower and resources, and it's prone to mistakes. So let me introduce Jonda X. Jonda X is an AI-powered transformation engine designed specifically to address this issue. How does it work? You take a file, any file, sounds like a magic trick, right? Take a file, this can be a HL7 file, could be a CCDA file, could be a Word document, could be a PDF, could be an image. We are compatible with 11 different languages. You drop the file into a folder, and magically, the result that you want comes out. This can then be sent on to your system, your clients, or you can read it back into your system so that your data is complete. No more data, manual data entry. So let's take an example. A lab sends you a report, a PDF. In this case, it's not even a PDF, it's an image of a file. You drop this into a folder. Different folders which you have predefined represent different templates. Each template could be, for example, template number 1, give me a HL7 file using this terminology, the Loink terminology. Template number 2, sorry, this is a fire file using a Loink terminology. Template number 2 could be a fire JSON file using a custom code with different sets of units of measurements. Template number 3 could be one of your clients using HL7, also using Loink codes, but different codes with different units of measurements. You drop the file in, that scanned image will be converted into the standard that you have predefined. That's all you do. Throw a file in, get the results. This is very secure because we do not retain any of your data. The moment the file is processed, we delete everything from our end. The folder belongs to you. You give us access to the folder. So it's 100% secure. As you can see, the data is transformed from enterocyte over to enterocytes by volume in blood, and I believe it is a Loink code 26453-1. Again, all of this can be predefined by you. You throw a file into the proper template. In this case, it would be Loink, coming out in fire JSON. The units of measurements would change, and if it needs to be recalculated, the value as well as the reference ranges will also change. Let's talk about personal identifiable information. We do not need that information in order to process this file, so you can totally redact that information from us. Also, because we do not retain any of that data, it's secure, as mentioned before. So, interoperability. We have standards that address the format of file. We have standards that define how messaging should be done. Transport. We have standards for terminology. In order to achieve true interoperability, you need something that can say enterocyte equals to Loink code. And straight away, you are Satu Sehat compliant, for example. Now, why did we choose InterSystems? I've worked with InterSystems for over 30 years, since the MUMPS days. And while we are in the healthcare business, InterSystems is in the business of healthcare care. They look after us. I haven't come across many providers that actually do that. Also, InterSystems is known for its blazingly fast speed. What you saw just now, processed in real time, with our servers sitting over in Frankfurt for this particular example, if it was a pure digital file, a HL7, it would take under 2 seconds. If it was a PDF or an image, it would take 7 to 11 seconds. In that 7 to 11 seconds, it runs over 6,000 lines of code, makes 8 external API calls, uses multiple OCRs and multiple large language models in 4 different embedded languages. So that's the reason why I chose InterSystems IRIS for Health. It's fast. The moment you scale, you need that speed. If you want to know more, you can contact us. Thank you so much. Thank you for your time.
Thanks, Daniel. So hopefully you enjoyed the presentations and you got some ideas, some inspiration for using IRIS in your own organizations to address some of the challenges you may be facing. And if you didn't have a chance to visit our partners' booths, you got the codes, and they're still here. Feel free to reach out to them. And with that, thank you.